Hi everyone. Today we are going to discuss about the mesh analysis. Okay. So we need to solve mesh analysis problem. For that we are going to use the Kirchhoff voltage law. Okay. You should know what is Kirchhoff voltage law. So Kirchhoff voltage law states that and in any closed circuit, mesh or loop, the algebraic sum of all the voltages taken around is zero. So this is the fundamental concept we are going to use to solve this problem. Okay. So if you are taking any complex problems, there are a number of loops will be there. Okay. So we need to choose a single loop and we need to sum up all the voltages. We need to find out what is the equation. Okay. That is the concept. So to solve this mesh analysis problem, we are using this Kirchhoff voltage law as we have already told. So there are procedures there to solve this problem. Okay. Uh, First one is, so these are the 5 steps mentioned to solve the mesh analysis problem. Okay. First one is you need to assume the unknown currents. Okay. So they will given the circuit. Okay. You need to assume the current like I1, I2, I1 minus I2 like that. You need to assume the current and you should mention its direction. Okay. So that is what's given in this first one. Okay. Uh, the second one is you are going to apply the Kirchhoff voltage law. Okay. So as already stated, algebraic sum of all the voltages around the closed path is zero. So we are using this Kirchhoff voltage law. We are going to solve. Okay. So we are going to represent all the terms using Ohm's law. Okay. So V is equal to IR. Okay. So this term, using this term only, we are going to represent. Okay. Based upon this, we have writing the equations. Okay. Then we are going to solve the equations and we are going to find out the answer. If the answer is coming as a negative, you should use this fifth point. Okay. If the answer is coming as a negative, you want to write that actual direction is opposite to that of the assumed direction. Okay. For example, if the answer is negative, you have chosen clockwise direction. You need to write that if you are chosen anti-clockwise, the answer will be positive. Okay. So these are the fundamental steps you should know to solve the mesh analysis problem. Okay. So this is the basic concept you should know. Okay. So potential rise. So potential rise means, for example, here if you take B1 minus 2 plus, okay, that is the potential rise. So you can able to see here minus 2 plus, okay, that is the potential rise. When you are seeing the potential rise, uh, we are using the positive sign. Okay. Similarly, you can able to see here this is positive to negative. Okay. A potential drop. If you see potential drop means you should put the sign negative. Okay. So based upon this only we are going to solve this problem. Okay. Then the last point you should remember is whenever the current is entering into the circuit, we are indicating as a positive sign. Whenever the current is leaving, we are indicating the sign as negative. For example, if you take this circuit, okay, if you take this circuit, okay, the current is starting from B1, okay. So first I will mention the current I1. So I have mentioned the current here as I1. Okay. Whenever the current is flowing from the battery to a resistor, okay, So the current is flowing from the battery to the resistor. Okay, like this it is, the current is flowing. When it is entering to this component, this is positive. Okay, so the current is coming from the battery and it is going to the resistor, so this element is positive. And when it is leaving, this is the negative. Okay, so the current is entering from the battery, it is flowing through the resistance R1. R1 is positive. Okay, so this term is positive. When it is leaving, it is a negative. Okay, so it is coming like this. This is positive. When it is leaving, it will be negative. Similarly, the current is going here. Okay, this is the thing you should remember. Okay, so whenever the current is entering into any element, so it will be positive. When it is leaving, it is a negative one. Okay, so you should remember all these procedures to solve the mesh analysis problem. Okay, now we will go to a circuit and we will try to solve the mesh analysis problem. Okay, we will use this basic circuit itself to solve this problem. Okay, so this is the circuit. Uh, for example, in this circuit, they may be asking to find out the current. So the question is find out the current in 2 ohm resistor. Okay, so this is the question they have given. This is the circuit. Okay, so we are going to solve this complex circuit. Okay, uh, first what the first procedure means, you need to assume the current and you should to indicate the direction. Okay, so first we are going to assume the current and its direction. So wait a minute. Okay, first we need to assume the current. Okay, so here I have mentioned the current as I1. Okay, so before I have mentioned the current, you should first name the circuit. Okay, So I'm naming the circuit A. So this point is B. This point is C. Okay, so I'm mentioning the circuit. I'm writing the each node. I'm writing the alphabet to find out what is the loop. Okay. So this is D. This is E. This is F. Okay, so I have mentioned the points node. Okay, so already you have know what is a node. Okay, the 2 point. So if you take this is the point. Okay, so the two elements joining we will call it as a node. Okay, so here there is a battery and here there is a resistance. If this two node is uh, so this is the battery, this is the resistance, so it is connecting, it is called one node. So this I mentioned it as a node A. So this is node B, this is node C, node D, node E, node F. Okay, so then I need to write the current. Okay, so first I have taken the loop A, B, E, F, A. There is two loop is there. One is first one is A, B, E, F, and the second loop is B, C, D, E, B. This is the second loop. Okay. So each loop we are going to apply the Kirchhoff voltage law and we are going to solve the problem. So first I am going to assume the current. Okay. So from the battery we are starting. Okay. So from the battery it is starting, the current is flowing. So I am taking the loop ABF. So from here it is starting and then the current is flowing towards the circuit. So the current is coming here. When the current is coming here, when it is entering this point is positive. So this point is positive. The current is entering here, this is positive. When it is leaving, when it is flowing towards this one is a positive. When it is flowing and when it is leaving, okay, this point is negative. So this one is a positive, this one is a negative. So I am giving the current is as, I have given the current name as I1. Okay, so this is the current I1. So this current I1 is flowing from this A to B towards this resistor, okay, I1. So at this point, when it's reached, the current is split up into two. One is downward direction, it is splitting, and another one is it is flowing through this direction. So I have named it as this as I2, and this as I1 minus I2. Okay, so there is a point, so current is splitting into two. Okay, so one is I2 and another one is I1 minus I2. Okay, so again we are going to check it. So the current is coming down. Okay, so this I1 minus I2 is coming down. So when it is coming down, what sign you should put? So you should put a positive sign. Okay, when it is leaving, it should be indicated as negative sign. Okay, so the current is entering into this resistor, so I have put in positive. So when it is leaving to the resistor, I have put it as a negative one. Okay, so this is the loop A, B, E, F, A. Similarly, if you take this, so the current is entering into this resistor, so I will be putting positive sign. And it is leaving, so we can take this. So the current is entering into this resistor, so positive. When it is leaving to the resistor, it is negative. Okay, so this is what the first step we need to do in the mesh analysis problem. So we have assumed the current I1, so this is I2, so this is the current this is the current I2, so this is I1 minus I2. So we have assumed the current direction, then we are going to apply the Kirchhoff voltage law. Okay, so first I have taken, the loop A, B, E, F, E. So I have taken it to a fresh page. So in the loop A, B, E, F, A. So I am starting from here. So it is a minus to plus. So it is a potential rise. Okay. So plus 28 volt. Okay. So in bracket I have mentioned it is a potential rise. It is a short form. PR is potential rise. Then the current is flowing here. Plus to minus. Plus to minus means potential drop. Okay. So potential rise, potential drop it is. So we need to mention it as a in terms of an Ohm's law. So when it is reaching here, it is mentioned as a 4 ohm. Okay, we are going to apply Kirchhoff voltage law. So we are going to apply Kirchhoff voltage law. Okay, So what Kirchhoff voltage law states that algebraic sum of all the voltage. So you should mention what is the voltage across this R1 or across this 4 ohm. Okay, so 4 ohm, what is the voltage means we know that Ohm's law, that is V is equal to IR, that is the Ohm's law. V is equal to IR, that is the Ohm's law. So we are going to apply the Ohm's law in this 4 ohm resistors. Then you will get it as 4, okay, 4I1, okay. So this is the voltage, okay, voltage across this resistance R okay. V is equal to IR, I is the I1, R is the 4 ohm. Similarly, we are coming to here, when it coming to this point, it is again positive to negative, so potential drop. So potential drop, so it is we need to mention the voltage across this 2 ohm, so it is minus 2I. So what is the current flowing here? Here the current is I1. So in this branch the current is I1 minus I2 equal to 0. So this is the Kirchhoff voltage law. So the algebraic sum of all the voltages across the loop is 0. Okay. So if I write the equation, it is 28 minus 4 I1 minus 2 I1 minus I2 equal to 0. That is minus 6 I1 plus 2 I2 equal to minus 28. So this is the first equation. Okay, so this is the equation number 1. Similarly, we can solve it for the second loop, that is B, C, D, E, B. If you take this loop, so here we are starting B. Okay, so here there is one resistance with 1 ohm. So it is plus to minus. So again, it is a potential drop. So directly I am writing it as minus I2. Okay, so minus I2. Then it is coming to a battery, 7 volt battery, that is plus to minus. Again, it's a drop. So it is minus 7. So again, I'm coming here. It is minus to plus now. So I'm flowing from this circuit, then the current is flowing this like this. Then again the current is flowing downwards. So it is flowing like this. So I'm taking this loop. So again this flowing from this. Then the current is flowing towards the upward direction. So when it is moving from upward direction, minus to plus. Minus to plus means it is potential rise. So we need to write here as plus 2 I1 minus I2. Okay. Then the loop is closed. B, C, D, E, B. Then the loop is closed. No element is there. So algebraic sum of all the voltages is equal to 0. If you write it as 2I1 minus 2I2 minus 3I2 equal to 7. This is the second equation. So if we solve this two equation, you will get what is current I1 and what is current I2. So if you got the current I1 and I2, you can able to find out what is the current in 2 ohm resistance. 2 ohm resistor is I1 minus I2. That is the answer. Okay. Similarly, you can take this circuit. So they have mentioned the loop. They have given the current direction also. So just I will mention the current. Okay. So here the current is I1. So the current is entering into this element. So this is positive. So this is negative. So the current coming here. So this is positive. So this is negative. So at this loop, the current is divided into 2. Okay. So this is a 1 and this is 2. So this current is I2 and this current is I1 minus I2. So this is I1 minus I2 current is flowing through this 5 ohm resistors. Okay. So this I2 current is flowing towards this, and when it's coming here, the current is split up into 2 again. So this is I3. So this is I2 minus I3. Similarly, here the current is splitted. Here is I1 minus I3. Okay. So when it is coming here, the current is here. It will be flowing as I3, I1. Okay. So here the current is I3. You can check it with using the Kirchhoff current law. So for example, if you have doubt, if you're taking this point E, okay, so if you take the E point, incoming current is, suppose if I'm taking E point E, the incoming current is I1 minus I2 at E. The incoming current is I1 minus I2 plus I2 minus I3. So the leaving is, if you cancel, it is I1 minus I3. So incoming current is equal to the outgoing current. So this I2 will cancel. So I1 minus I3. This is what the current will be flowing towards this point. Okay. So we have assumed the current direction. Then we need to write the equations. Okay. Same procedure what we have discussed. Then we need to solve and find out the current.